If we could first know where we are and whither we are tending, we could then better judge what to do and how to do it. Have you ever heard of the question, does the flap of a butterfly's wings in Brazil set off a tornado in Texas? Posed by Edward Lorenz, the question is often interpreted by people to be that small things have big impacts, and that a system could be manipulated to get a desired outcome. However, the professor intended to convey how a nonlinear system may be so unpredictable that a small change in a state could have either little or profound effects on the result. Lorenz was repeating a simulation of weather patterns when he found that data which is rounded off had a remarkably different result from unrounded data. From this, Lorenz knew that standard weather prediction models are not entirely accurate, as completely knowing the starting conditions is impossible. Hence, an alteration could drastically change the statistics, or not. Think of it this way. A tornado is predicted to be formed at 1:47 a.m. and move southeast. However, due to a butterfly flapping its wings thousands of miles away, the tornado was formed at 1:52 a.m. and moved south instead. The butterfly's flapping wings resulted in slight changes in the atmosphere, which delayed the tornado's formation as well as its direction of movement. To think that just a small little organism could impact this massive influx of wind, isn't that amazing? On the contrary, the tornado could still have followed its predicted path, or could not have been formed in the first place. There are countless possibilities of outcomes, and yet knowing the end result with complete certainty is out of the question. In this scenario, the tornado represents a nonlinear system, while the butterfly is an example of an unknown condition that could easily change the results. Even as far back as the 1890s, the butterfly effect can be seen when French mathematician Henri Poincaré attempted to solve the famous three-body problem, which basically consists of using Newton's laws to predict the motion of three bodies exerting a gravitational force on one another. However, as he stated in his discovery, if we knew exactly the laws of nature and the situation of the universe at the initial moment, we could predict exactly the situation of that same universe at a succeeding moment. But we could still only know the initial situation approximately. Small differences in the initial conditions produce very great ones in the final phenomenon. In other words, even if the initial conditions differ in a very minuscule way, down to the atom, they can produce vastly different results in the subsequent motion of the system. And that is what the butterfly effect is essentially about. You might wonder, why exactly does this happen? Here, it is important to stress the property of nonlinearity. When the system is nonlinear, it means that the small differences in initial conditions actually get magnified as the calculation progresses. To put it into context, imagine you have two numbers, 4 and 4.001. Right now, they only have a tiny difference of 0.001. But when you take those two values and chuck them into a nonlinear system, for example, squaring those numbers, the difference gets bigger and bigger and bigger. The more the numbers are squared, the larger the difference, to the point where you get this. This is essentially what a nonlinear system does, unlike a linear system where the difference stays the same no matter how much calculation is done. The butterfly effect is most commonly demonstrated in weather predictions, where models are extremely sensitive to small errors such as rounded data. However, some climate scientists argue that the direct impact of the butterfly effect on weather forecasts is not as significant as others have made it out to be, especially regarding predictions of the very near future. Nonetheless, the effects of this phenomenon should still be considered in such predictions. Although humans may try to predict the future, they also need to know that nothing is absolute in the larger scheme of life. As cliché as it might sound, life is unpredictable to a certain extent.